Okay. Come. First, let's see these two tools. Okay, Sketch Tools Toolbox and User Selection Filter Toolbox. In Sketch Tools Toolbox, the first one is grid. If we need to turn on grid, just like in AutoCAD, we can turn on and off grid, and the grid dimensions can be controlled from Tools, Option, and currently you see this is not visible, right? Just move your cursor there, hold control, sorry, without control, just zoom in. Sorry, hold control and zoom in. Okay. Then uh, under under mechanical, under sketcher, we can change the spacing here. You see, the grid spacing can be controlled here, and also the graduations. There are six graduations, okay, minor divisions, and this is the primary spacing, and give OK. And when I am selecting this tool and drawing, you see, from here to here it will be 10, and from here to here it will be 100. And also there is an option for snapping, snap to point. When the snap to point is turned on, I can sketch through these points. Understood? Okay. I'm also putting some points here and there. Okay. So that is 1 minute, Vishnu. I'm having. Okay. Ah, okay. So that is the purpose of grid, uh, grid and snap. Then we have an option called the construction or standard element. If that construction mode is on, the lines which we draw will be only seen as dotted one. It will be acting as a reference lines only. Okay, just like a yes, yes, I can hear. Okay. Now it is audible, right? Okay, fine. Ah, yes, same. If I want to change it to a standard line, select that line, turn off this construction of standard elements, then it will be a standard line. Okay. If I'm turning on it and drawing, it will be coming only as as a dotted line. If I want to make this to a dotted line, select that, go to construction of standard element, click on that, it will be dotted line. Understood. Then we have one tool called construction standard geometry constraint and dimensional constraint. I will explain that while after coming to this constraint, this geometry constraints. Okay, let it be turned on initially. Then we have a tool called the user selection filter. The first one under the user selection filter is point filter. If point filter is turned on and we are making a box selection, only the points will get selected. Did you notice? Okay, fine. Okay. If under user selection filter, if this point filter is turned on and we are making a box selection like this, only that points will be getting selected. Understood? Sorry? That is the use of selection filter. If nothing is turned on, everything will be selected. Okay. If curve is turned on, only the curve will be selected. If there are some say if there are some solid and all, it won't be getting selected. I will show you. Yes. Curve means lines or arc or point, anything will be selected. If there is some surface bodies alone and we have to select the surface bodies only, make sure that under user selection filter, surface filter is turned on. If it is if it is entire volume, if only the solid body has to be selected, turn on this one volume filter. Okay, that are the functions of these things. If we have to select only a feature, turn on feature element filter, then not the entire geometry, only a certain geometry, for example a fillet like thing, or consider there is a two extrudes like this. I will show you. Exits. On this sketch, this plane itself, I am drawing a new sketch. Okay. Let the mode be shade with the edges. Okay. You see, only this feature got selected, not the entire geometry. Only the certain features like this pad or this planes got selected when this feature element filter is turned on. Understood? If the volume filter is turned on and I am making a selection like this, only that solid will be getting selected. Okay, under volume filter. Actually, it is not selecting the pad, right? It shouldn't happen like this. Let me check what is that. Uh, volume filter. I think some other options are turned on. Let me see. Okay, and also you see one thing here. When I am deleting an object, I selected, when I am deleting that object, there is an option called delete aggregated elements. Uh, when that turn when that option is turned on, I will show you. You see, with related to this pad 2, there is sketch 3, right? If I'm turning off delete aggregated elements, that is sketch 3 will be remaining. That pad will be going. I am again undoing Control Z. Sorry, read. No, it is not. I'm again extruding. Okay. And I'm again deleting. Right click, delete. Here I'm not turning off this thing. Delete aggregate element means that sketch 3 will also will get deleted. Okay. Okay, then depending upon our use, if we need to select only the curves, make sure that curve filter is turned on. You see only the curves get selected, and I have deleted the curves easily. The solid parts are not getting selected. Okay. Similarly, the surface I can use. Okay, that is some options under user selection filter, and then we are going directly to this toolbox. Okay, this means profile toolbox. Profile toolbox. Under profile toolbox, the first option is profile itself. Just like our polyline. In AutoCAD, we have profile toolbox. You see, when I'm drawing profile line, it can be made as a continuous entities. Or if I am clicking here and dragging like this, it can be converted into an arc also. Just draw like this, left click, drag it down or upwards. It will be converted into an arc like this. Okay. Okay. Then we have the second tool is rectangle. It is not just a rectangle. When I am dropping it down, I can see there it is called a predefined profile. Predefined profile. The toolbox is called the predefined profile. And after that, there are some certain options. First one is rectangle. Easy as that, two corner points to define a rectangle. Then we have oriented rectangle in which we will be mentioning 3 points, and the difference between the previous one is that it can be oriented along an axis. It can be inclined. It can be inclined at an angle. Okay. Yes. Ah, just call the shift. Just hold shift. Select the toolbox and hold the shift or control. Both will work. Oh, sorry, no control. Okay, shift only. Shift will be working. Ah, here or here. Here. Ah, yes. Anywhere we can keep it. Okay. Which one? No, not requirement. Only requirement. Yes, there is no rules. Wherever we like. While I do CATIA, most probably I'll be placing the tools here in this region where I can reach my mouse pointer first, not on this corner. The tools which I use very rarely are kept on on the corners. Okay, this I usually don't keep these tools here. This tool is some required one. Okay, then we have profile toolbox, then predefined profile, rectangle, oriented rectangle, 3 points in oriented rectangle. Okay, first point, second point, and third point. It will define the rectangle. Then we have parallelogram. For parallelogram, what we do is there also we will be giving 3 points. One, two, three. Is it? Okay. Then we have elongated hole. Under elongated hole, what we do is 1 point, 2 points, and then we have uh, third points. 1 point, 2 points, 3 points to define an to define a what what we call this tool in SolidWorks slot. Then we have cylindrical elongated hole. For that also same, just like drawing an arc. And if our starting point is this, move our cursor to if this, move to this point, draw our arc, then finish the curve. Okay. Then we have keyhole profile. For drawing keyhole profile, that is a tool we don't use much. Depending upon the application only, we will be using this keyhole profile. Okay. And I haven't seen much use of this keyhole profile. Okay. For that, first point, second point, third point, then fourth point. First point, second point, small radius, large radius. Okay. Then we have hexagon, very important or very commonly used tools. Hexagon. There is no polygon, only hexagon is available. Okay. Then we have a tool called center rectangle, center point and end point, center point and an end point. Then we have centered parallelogram. For that we need two lines. Okay, we need two lines like this, and the intersection point of that lines will be acting as the center point of the parallelogram. There is one parallelogram which we did by using 3 points. It is centered centered parallelogram. For that, first select this point and in this point. The intersection of that 2 point will be taken as the center of the parallelogram and it will be completed like this. Understood. This is called a predefined profile. Under profile tool. The second set of tools under profile is predefined profile. Okay, very commonly used tool. Then we have circle. Circle also there are some sub option. What is that? Okay. Hearing the sound, I thought something fell down or something like that. First, under circle, the first one is the main common circle, center point and radius. Then we have 3 point circle. I think we already have said about 3 point circle in our AutoCAD and SolidWorks and all, right? In 3 point circle, what we do is we will be mentioning 3 points. One, two, three. And connecting that 3 point, there will be only one circle. Then we have a option called circle using coordinates. When I click on that, I will get a dialog box, and it is having two options: Cartesian or polar. Cartesian means, you see there is a X and V that represent the X and Y location, the center point of the hole and the radius. I am saying radius as 7.5 and the center point as let me tell 25 0. Okay, X Y 25 0, and this was so much zoomed out. Okay, it's 25 0. You see here it is 25 0. X coordinate and Y coordinate. You see, it was not normal. It was a little perpendicular. It was little disoriented. Click on this view. Okay, click on this normal view so that our view is aligned with the plane. How did I understand? I understand it because somehow accidentally I did it. It is not aligned with the origin and all. That's how I understood that. And also there is some other way to understand that. That is, uh, the line will be not straight. Some like some graphic issues. Straight. No, that is not an apt way to identify. Okay. Okay. Then we have the second option, which is polar. Here, instead of mentioning the coordinate values of the center point, what we are mentioning the angle and the radius. By Cartesian method, by polar method, we are mentioning the center point. You see, 25. I'm just deleting this. This. You see, under polar 25 angle, I'm giving it as 60. No, no issue, no issue. 25 and 60. And the radius is again, I'm giving it. You see, 25, 60. The radius location we got, and sorry, center point location we got, and the radius value 8.5. Okay, this Cartesian and polar methods to draw a circle. Did you notice one thing? When I am drawing like this, it is in green color, sorry, white color, and when drawing like the other way, or by using some specific location and all, it is in green color. I think as you have, SolidWorks, you have guessed what it is. Yes, fully defined and underdefined. Fully defined color code is green, underdefined is orange. And in SolidWorks, sorry, in CATIA, it is not called by the name fully defined and underdefined. It is said by the name mm, under constrained or ISO constrained. Okay, okay. ISO constrained means fully constrained, not fully. Okay, I will show you how to check that thing. Uh, After finishing that drawing tools, we will move to this tool. Okay. That will be better. There is a option like just sketch solving status, just to see the status of the sketch. Ah, okay, let me check. No problem. Some network issue. Okay. Ah, yes, we will be saying about that in after saying all the profile tools and operations tools. We can go to that thing. Okay, to check whether the figure is fully constrained or not. Okay, then we had an option called a tritangent circle. Uh, in that, if I am mentioning three reference points, mm, it will be tangent to that. Okay, well, I will show you. Tritangent circle. Under tritangents, one, two, three. You see, the newly formed circle is tangent to all the three things which we said. Or if I'm saying three curves or three circles also, it will match one, two, three. Tritangent, tritangent circle. Okay. Then we have 3 point arc. Under 3 point arc, as you guess, 3 points. One, two, three. Connecting that 3 points, we will be getting an arc. Then we have an option called 3 point arc starting with a limit. What is the thing? No dimension. Here you see the order was one, two, three. Here the order is one, two, and any points. First point, last point, and between point. You see, first point, last point, and an in between point. Oh, this one, because this point is not the last point which I mentioned is not a fixed point. It was an arbitrary point. If it was some fixed point, it might be fully defined. You see, one, two. If I was making coincident with this thing, that is fully defined. But here I didn't coincident with any points, right? That, okay. Then we have uh, 1 minute before. Hello. Okay. Now till where we were. Okay. Then the last type of arc is center point arc. Center points, then starting points, ending points. Understood. That is the way to create arc. Different types of arc in CATIA. Okay. Fantastic. Then let's move to next set of tools under Sketcher itself. Just clearing the window. Okay. The next one is spline. In spline, we have two tools, spline and connect. Spline is for drawing. Spline. That's it. Okay. It is much easier to control using these spline points and all. Then, this connect tool is connecting those splines. That's all. Okay. That is spline and connect. Then we have a set of tools called conic. Under conic, the first one is ellipse. Just mention the center point and two endpoints. And then we have a tool called parabola by focus. The way to draw is draw the focus point, directrix point, and starting point and ending point of the spline. Sorry, of the parabola. Then we have a tool called hyperbola. For hyperbola, also it is like that. Focus, directrix, then starting and ending of hyperbola. First mention the angle, then starting and ending of the hyperbola. Then we have an option called the conic. Parabola, hyperbola, and conic. For drawing this conic, what we need is mention two lines like this. Okay, then increase. You see, these conic will be tangent to these two, and it can be a hyperbola or a parabola or an ellipse. Okay, some calculations has to be made for controlling whether it is a hyperbola or parabola and all. I think you remember about the raw value which we used to do in our SolidWorks. Raw, raw. Do you remember about the raw value? I will show you. Uh, Okay, depending upon that raw value, this thing will be changing and it will be. You see, this is the line which we draw first, and depending upon the length from here to here, and also the length from here to here. The ratio defines whether that is a hyperbola, parabola, or ellipse. For ellipse, it will be less than zero point 0.5. For parabola, it will be zero point 0.5, and hyperbola is greater than zero point 0.5. And for circle also, there is some value. Okay, but I actually don't remember the value. For circle, there is some value. If that is 0.22 or something like that, then it will be a circle. No, it is not showing. It's showing something. Row in circle. It showed row in circle. Okay, just a refer. Okay. I think if I'm right, if I'm not wrong, it is there. Some value is there for circle also. That is a way to draw conic using profile tools. Then we have line. Under line, there are different sub options. First one is our normal line, and then we have our infinite line. Okay. Then we have then it's not this one. Third one, it is bitangent line. Bitangent means consider that there are uh, two circles like this. If I need to make a what? If I need to make a click here, it will be tangent. If I'm clicking here first and here, it will be tangent like this. Okay, depending upon what it. Then we have an option called bisecting line. In bisecting line, what it does is it will be bisecting two lines. That's all. Right. Yeah. First one, second one. It will be bisecting like this. Okay. Then we have something called a line normal to curve. Under line normal to curve, the thing is, if see if I'm selecting that and clicking on this point, I can get a line which is normal to that point. In other softwares and all, what we have to do is we have to draw a line like this, give the tangent points, give the coincident points. Then we have to draw a line perpendicular to that. You see, we have to give tangent like this. We have to give coincidence like this. Then from that point, we have to draw a line. Here, there is a direct tool that's it is instead of drawing such things, we can directly draw a perpendicular. Okay, that's it. This line, maybe it is not normal. Let me see. No, it is normal. Maybe inclined or something. I think it's showing some graphics issue uh, in overall. You see, I will show you one thing. When that grid was turned on, did you notice one thing? When I was rotating it and all, now it is okay. Earlier, then now also it is breaking from here. It shouldn't happen like this, right? Um, I have to see whether my graphics card is turned on or not. I believe it is turned on, but I have to look it once more. Okay, okay, okay. Mm. Then, then, axis. Axis is not our dotted line. It is something else. While giving rotation and all, it will automatically look for while revolving and all. If there is an axis defined, it will automatically take that as the axis line. Okay. Uh, then It can be vertical or horizontal. Okay, any way it can be, or inclined also. Okay, anyway it can be. Then we have points. There are number of ways to give point. By just clicking, we can give, or by giving coordinate value. You see, I'm giving 50 comma 0. Okay, you see under 50 comma 0, it is not 50 comma 0. I think I did something else. 50 comma 0. I was too much zoomed in whether. Let me just check the dimension from here to here. Ah, I was very much zoomed in. Okay. Here, did you see the dimension? That is so large value. 100 comma 0. You see, 100 comma 0. There's a if 100 comma 20. Under 100 comma 20, there is a points. Okay. Fantastic. Okay, then we have equidistant point. Equidistant point will be working on a line. Uh, Select equidistant point, click on that line, and give the number of points. I am giving 5 and giving OK. You see, 5 points equally spaced. Then we have intersection points. If there are two lines like this, and I am giving intersection points, clicking on this thing and this thing, at the intersection of the two lines, there will be a points. Okay. Then we have projection points. Projection point means consider that I have to project a point from this end to this line. Go to projection point, select this point, click on the line. It will be projected. That point will be projected to here. Okay. This is all about the profile tools. Understood? Hello? Play. That is different. That is different things only. It is different things. Similar to our convert entity, there will be a tool here. Okay. Okay, Bisharup. Bisharup, let's continue after a short break. Okay. Anything is fine. Let's let's begin by now. It is what is the time? Seven, seven, right? It's 6:52, right? Well, let's continue by 7:10. Okay.